A very good morning to everybody. I welcome you all for this session 23. In this session, we will learn about degrees of freedom, space point, and configuration space. Let's recap of what we studied in previous classes. We learned about constraint, which is a limitation or restriction imposed on the motion of a body, and their types, namely holonomic, non-holonomic, scleronomic, and rheonomic types of constraints along with their examples. The learning objective of this session is to understand degrees of freedom, a space point, and configuration space. By the end of this session, you will be able to understand what do you mean by degree of freedom, space point, and configuration space. The motion of a particle along its path can be described by its position vector. That is, r is equal to r as a function of x, y, z, t. Let us consider a particle moving in a straight line. To describe the motion of a body moving in a straight line, I need either x or y or z coordinate to describe its motion, which means I need one coordinate to describe the motion of a particle moving in a straight line. Let us consider a particle moving in a plane. To describe its position, I need x, y, or y, z, or zx coordinates, which means I need two coordinates to describe the motion of a body in a plane. If a body is moving in a free space, I need all the three coordinates x, y, and z to describe its position at different intervals of time. These minimum number of independent variables or coordinates required to specify the position of a dynamical system consisting of one or more particles is called as degrees of freedom. A particle moving in a free space need 3 degrees of freedom. A two particle system need 3 plus 3, which is 6 degrees of freedom. 3 particles need 3 plus 3 plus 3 for each particle, that is 9 degrees of freedom. Likewise, for a system consisting of n particles moving freely in space, we need totally 3n independent coordinates to describe its position. Hence, the degree of freedom is 3n. Now let's look some examples. A monoatomic gas, which is like a particle moving in a free space, I need totally 3 degrees of freedom. Example, helium, neon and argon. For a diatomic molecule, there are 2 particles which I need, therefore totally 6 degrees of freedom. However, if one of the distance between them is fixed, so 1 degree of freedom gets reduced. So the total degrees of freedom is now 5. Likewise, for a triatomic molecule, the degree of freedom is 9. However, if there are 3 constraints, so the degree of freedom reduces from 9 to 6. For a triatomic linear molecule, the degrees of freedom is 9. However, if there are 2 constraints, the degree of freedom is reduces from 9 to 7. So we see that if the constraints are imposed, the degrees of freedom gets reduced by the number of constraints present in that system. Likewise, if a particle involving k number of constraints, the degrees of freedom for such particles will be 3n minus k. So now we can define degrees of freedom as the minimum number of independent variables or coordinates required to specify the system compatible with constraints. This is degrees of freedom. Likewise, the configuration of a system of n particles moving freely in space may be represented by the position of a single point in 3n dimensional space is called configuration space of a system. Example, the configuration of a system of 2 particles can be represented by the position of a single point with 6-dimensional space. So this system has 6 degrees of freedom and its configuration is 6-dimensional. Note that space point in configuration space represents the position of a constituent particles. So my dear students, we learned what do you mean by degree of freedom, which is the minimum number of independent variables or coordinates required to specify the system compatible with constraints. And for a system of n particles moving freely in space, they can be represented by the position of a single point in 3n dimensional, which is configuration space of a system. So now let's have a small MCQ session. Question number 1. The degree of freedom for a free particle in space is 3. Question number 2. The degree of freedom for n particles in space is, answer is 3n. The number of degrees of freedom of a system of n particles subjected to k constraints is, answer 3n minus k. Question number 4. The degree of freedom for a linear triatomic molecule, it is 7. The degree of freedom for a diatomic molecule, it is 5. The degrees of freedom for a triatomic molecule with no constraints imposed. If there are no constraints, it is 3n. So 3 particles, 3 into n, that is 3 into 3 will give you 9. So answer is 9. Question number 7. The degree of freedom for a non-linear triatomic molecule is, Answer is 6. BeCl2 is an example for non-linear triatomic molecule. Question number 9. Carbon monoxide is an example of, it is like heteroatomic. Question number 10. Space point in a configuration space represent dash of the constituent particles. It represents the position of the constituent particles. Thank you all. Hope you have enjoyed this session.